Okay, yes, okay, my dear learners, over there, I welcome you once again to our lesson 25. So in this lesson, we are going to start with our word bank as we normally do it. So we have 9 words which we are going to spell and get to know their simple meanings. So let us start with this word here. So this word is read as theallin, and this is theallin. This is read as theallin. So what do you know about theallin? So this is an enzyme. So remember we said enzymes are chemical substances that help to speed up digestion of food. And which type of digestion is that one? That is chemical digestion. So this theallin is also called the salivary amylase, which is found in the mouth. So found in the mouth in the digestive juice called the saliva produced by the salivary glands. So this is theallin. So it acts upon the cooked carbohydrates or the cooked starch. All right, so let us get another word here. This is read as duodenum. This is duodenum. So this is the first part of the small intestines. As we all know that the small intestines are made up of 3 parts. The first one is the duodenum, then we go to the jejunum, and again we end up with the ileum. Right, now this duodenum, it is where emulsification of fats takes place, the breaking of fats into small droplets. That is called emulsification. It is called emulsification. So here is where fats are being broken down by the help of a juice called the bile juice, which is produced by the gall bladder, produced by the liver and stored in the gall bladder. Okay, so here we have this other word, potential, and most of the people fail to write this word potential. So it is just very simple. You write pot, then we form another word 10, then from 10 we form 20, then shell. So the word becomes a potential. So this potential is the type of mechanical energy. Remember we said energy is the ability to do the work. So we have types of energy and there are 2 of them. One of them, it is potential. So this is the form of energy possessed by objects at what? At rest, like you is seated there, like the saucepan there, the jerry cans down there, the phone on a table, a baby in a cloth, in a baby coat, and so on, water in a jerry can. So that is what we call a potential energy. So it is possessed by objects at rest. Okay, so let us get this other word here. This other word is read as solvent. The word is a solvent. What is a solvent? So a solvent is a substance that dissolves another substance. Remember we said a substance, this is a material made up of one kind of matter. If it is a liquid, it is a liquid. If it is a solid, it is a solid. So it is a substance that dissolves other substances. For example, water can dissolve sugar, then water becomes a solvent. So a solvent is a substance that can dissolve other substances. Are we there? Now let us get this other word here. This word is sorghum. This word is what? Sorghum. It is read as a sorghum. Do you remember sorghum when you looked at flowering plants and crops? So sorghum, yes, this sorghum is under the cereals like rice, like millet, like wheat, like oats and barley. So this is sorghum. So it is under cereals. Its seeds has only one cotyledon like the maize. Okay, so this word is pneumonia. So this pneumonia is a disease. This is read as pneumonia. So this pneumonia attacks the lungs. It can attack the rabbits. At the same time, it can affect the human beings, as we can get it, the babies, and also it can affect our birds, the poultry. Remember we said poultry means the birds kept at what? At home. So this one is pneumonia, and is caused by a bacteria called pneumococcal. It is pneumo, this is pneumo, then coco. So pneumococcal. So we have these other 3 words remaining. Let us start with this word here. This word is read as mar, then chur, then re. So this is maltry. So maltry, it is a liquid which is used in most of the the thermometers, as we've been discussing. So why it does not stick on the walls of a thermometer? This mercury expands evenly, and this mercury it's a conductor of heat, and this mercury can easily be seen. It is opaque, which makes the reading reading easy of the results. So, and this mercury, it is special in a way that it is a liquid, at the same time it is a metal. So mercury is a liquid metal. Okay, so let us take this one. This one is called as evaporation. In the previous lesson we looked at changes in the states of matter, and we said what causes the changes in the states of matter. That is the change in temperature. When the temperature increases, we are expecting to get a change in state of matter, or when the temperature reduces, we expect to get a change in state of matter. Now with evaporation, here we are having temperature increase. For example, if I have my liquid here and I heat it, now the temperature is going to increase. When the temperature increases, the molecules are going to move very fast, thus they turn into a gas, and this is what we call vapor. So this is evaporation. Now when you're writing the word evaporation, we don't put you, but some members make a mistake of putting you here. No, we don't put you there. It is just evaporation, just like this, without letter U. So this is the process by which a liquid turns to what? To a gas, right? Okay, so lastly we have our word here. This is adhesion. The word is adhesion. It is the opposite to which word? Cohesion. As we discussed earlier, we said cohesion, these are forces of attraction between molecules of the same substance. Now today we are looking at cohesion, the forces of attraction between molecules of different. Now when we look at DCD, DCD stands for different. This stands for different. So cohesion, these are forces of attraction between molecules of different substances. For example, if you have a plate and water, so after washing a plate, then water is going to remain on a plate, meaning that the molecules in a plate, they are attracting the water molecules. Water is a different substance and the plate is a different substance, because this is a solid and water is a liquid. Now we are having that attraction. So that attraction between the two is what we call adhesion, right? That is called adhesion. So adhesion forces are the forces of attraction between molecules of the same substance. Are we together? Right. So adhesion is the opposite of cohesion. Cohesion, molecules of the same substance. Adhesion, different substances. So forces of attraction between different substances. My dear learner, have you understood the words for today? We have had the word like evaporation, partially, pneumonia, sorghum, solvent, duodenum, potential, molecules, mercury, and adhesion. So that has been our word bank for today. Now let us move on and see the science diagram for today. All right, so here we are having a grain. So it is a grain, at the same time it is a seed. What is a seed? We say that a seed is a mature, or acid is a mature, acid is a fertilized ovule from the ovary, and we have two types of seeds. One, the seeds with one cotyledon, which you call monocotyledons, and the seeds with two cotyledons, which you call dicotyledons. Now when you look at this grain we are having here, it is a monocot. It has only one cotyledon. So monocotyledon seeds, one we said they undergo what we call the hypogeo germination, meaning that their cotyledon remains inside the soil, and two, they have what we call these seeds. After germinating, they have root system, and that root system is called the fibrous root system. And when you look at the leaves of these plants, these leaves have what we call they have what we call a parallel leaf venation, and these leaves, they have what we call a sheath. They have a sheath instead of a petal or a leaf stalk. Now we are going to take the naming of our maize grain. And before we continue, this maize grain, it is special. Why? Because instead of being called a fruit, it is a seed, it is called a fruit, simply because it behaves like fruits. These fruits have two scars. One, they have what we call a style scar, as we discussed, and also what we call the stalk scar, as we discussed in the previous lessons. Now let us take the diagram here, the drawing. Just now, when I'm taking this drawing, this one is the outer cover, which we call the seed coat, and we discussed this. So we say the seed coat is also called the tester, but here we are just reminding ourselves. And the tester protects the inner parts of a maize grain. Now we have this upper bulging, this bulge, it is called the style scar. So this was the connection to the ovary, so the style scar. Then down here we are going to get this scar, and now this scar is what we call the stalk scar. Now this scar is very important in a way that it holds the grain onto a cob. So you know a cob, a chikongoliro. So if this is the chikongoliro, it has holes, then this thing will fit into this space of the chikongoliro, then we get the grain. Then this one fits inside here, then we get the grain. Now this one is what we call the stalk scar. So its work is to hold the grain out to arc the grain to arc this one, the grain onto the maize cob, not comb but cob. All right, so now let us now take the internal parts here, then we are going to make this section. So all this section I've made here, it is what we call the cotyledon. Then here, this remaining part here is what we call the endosperm. That's why we are calling this one a monocot, because it has only one cotyledon. So the importance of this big space here, it is a food store. So this one stores food. This one stores food for the embryo. Remember we discussed the embryo. Now let us remind ourselves. We say the embryo is made up of two parts. One, it is made up of the plumule, and two, it is made up of what we call the radicle. Are we there? Now the plumule, we said this plumule on germinating, it is going to grow into a shoot system, and this radicle is going to grow into the radicle grows into a root system. And which system is this? This is going to be it's going to be the fibrous root system. Let me hope that you are following me there. Okay, now inside this part, let us put our now embryo. Now we have two. Now we have this. There are two. This one is what we call the coleemptile. This one's called the coleemptile. Then this one, the second one, is what we call the plumule. So the importance of the coleemptile is to protect the plumule. Now this plumule is done to grow into a shoot system. Then down here we have two. This one's going to the coleemptile. It is called the coleohesa. This one is called the coleohesa. Now this coleohesa is also called the radical sheath. Its work is to protect the radicle. Then this part here, this portion, is what we call the radicle growing into a root system. Now the combination, the general name we give to this radicle and this plumule, it is the embryo. Now the food for this embryo is stored in the endosperm. So which part is going to get it from the endosperm? It is this part here, which we call the cotyledon. Therefore, the cotyledon of a maize grain, it is special from those cotyledons of beans, of the dicots. Why? This one, for it has one function. What is that one? To absorb food from the endosperm and supplies it to the embryo. It absorbs, gets food from the endosperm and supplies it to the embryo. Our embryo, we mean the radicle and the plumule. The radicle protected by the coleohesa and the plumule protected by the coleemptile. All right, now let us now compare what you have drawn here with what we are having here. Automatically, this large section here, let us change the color so that we see this clearly. Let us, should we use black? Oh gosh, let us use maybe blue. We take dark blue. Can this blue work for us? Let us take this blue. Now all this one is what we have called the endosperm, right? So its work is to store food for the grain. Now this section here, it is what we've called the Cotyledon. Now this Cotyledon absorbs food from the endosperm and supplies it to the embryo. Now this is what we call our plumule, and this one is what we call the radicle. Katika naka wansi is what we call the coleohesa. It is called coleohesa. Pronounce it now, coleohesa. Say coleohesa. It is coleohesa. Good. Now its work is to protect the radicle. Yes, that's good of you. Now this part here, it is what we call the coleoptile. This is what we call the coleoptile. Gamba coleoptile. It is coleoptile. Good. Now this coleoptile, it is protecting our plumule. So we shall not name these ones because at our level we don't need to know about them. So this is the radical sheath, the coleoptile protecting the plumule. This is the radical being protected by the coleohesa, the endosperm supplying food to the embryo, storing food for the embryo, and the cotyledon absorbing food from the plumule, from the endosperm and supplies it to the embryo. Now down here it's where we have our stochastica, and up this way is where we have the stylisca. Now this outer covering here, it is what we have called the tester over the seed coat, protecting the inner parts of the grain. My dear learner, have you remembered name labeling the maize grain? Remember, we've said it's called a fruit. Why? It has two scars and it is under what you call monocots, simply because there's only one cotyledon. On germinating, it shows what you call hypogeogermination, and its plumule, it is protected by the coleoptile, whereas its radicle is protected by the coleohesa. The maize plant has what we call fibrous root system with pearl leaf venation, and the leaves have what we call a sheath instead of a leaf stalk. Good. That's good of you. No, I know that you've understood it. Alright, anyway, let us now continue and see what we are supposed to study today. Alright, today we are now going to look at what we call solutes, solvents, and mixtures. What? Solutes, solvents, and mixtures. Let us start with what we call a solute. Pay attention, concentrate, listen. This is very simple. You don't need to stress. Just smile. So when you smile, it makes you to be wiser. Okay, now what is a solute? We are going to define our solute as a substance which dissolves in another substance. Let us take two things here. Let us get our sugar, and again let us get our water, then let us get our cup. So in this cup, let us put our water, then after we pour there our sugar, then what are we going to do? We are going to stir. Now as we stir, what are we going to observe? After some time, we are going to get a clear solution. Actually here the product we have obtained is called a solution. Now the sugar has disappeared. The sugar has done what? The sugar has disappeared. Where has it gone? It has entered the water, and that disappearing is what we call dissolving. Is what we call it has to be with the two s's. That is what we call dissolving. That is what we call, everybody, dissolving. Now the sugar has dissolved. Where has it dissolved? Where has it entered the water? Let us get another example here. We can get our water, then we get our sand, then we put sand soil here. Now we stir. Then after some time, what are you going to observe? The sand is going to settle down. Now this sand has not dissolved. Then we are going to get another scientific word. Now these things which don't dissolve in water, we call them insoluble. We call them insoluble, like a majani. So some tea leaves, they don't, just few particles of tea leaves dissolve, but the rest remains. Therefore they are insoluble. Now this sugar has entered the water, has disappeared, has dissolved, so it is called soluble. So why has sugar dissolved? Sugar has dissolved because it is so soluble. Then sand has refused because it is insoluble. Therefore This thing which has dissolved is called a solvent. So a solute. So a solute is a substance that dissolves in a solvent. So a solute is a substance that dissolves in another in another substance. So here we are using English. So a solute is a substance that dissolves in another substance. Whereas a solvent is a substance. Now a solvent is a substance that dissolves. Ekimira ne kyebamira. So ekimira is a solvent, then kyebamira is a solvent. So okukimira, that is being dissolved, then okumira, that is to dissolve. So a solvent is a substance that dissolves other substances, whereas a solute is a substance that can be dissolved by another substance. Now let us get what we call some examples of what? Of solute. C1, there is solute. 2, there is sugar. 3, we are having glucose. We have glucose. There is glucose. Then 3, we also another, we have powdered milk, latto milk. We have that powdered milk. So these are the best examples of a solute. C. Then let us look at solvents, the substances that dissolve others, ebimira ebirala that dissolve other substances. Now let us get examples. The best one is water. Then we have what we call the methylated spirit, and also we have petrol, we have diesel, we have ethanol, omwenge, ethanol, and so on. So these ones are what we call a solutes. Let us get another chalkboard here, a clear one. Now when you look at this water is going to be a unique one. It is called a universal solvent. Why? Because universal means almost all. So water is called a universal solvent because it dissolves it dissolves almost, si byonna, but almost all solutes. It dissolves almost all solutes. So now let us take this one. So what is a solution? So a solution is a mixture of a solvent and a solute. So is a mixture of a solvent and a solute. Like when I have my sugar, then I add there water, then what I'm getting is called a solution. Now let us look at what we call actually, before leaving a solution, we have what we call SS. This is what we call sugar salt solution, or you can start with the salt sugar solution. Now, and this solution is a mixture. Now this one is leading us to what we call mixtures. Then what is a mixture? So a mixture is a combination of two or more substances. Is a combination of two or more substances. Is a combination of two or more substances by physical means or physically. Kanokakulu, you have to put this word here, physically. So it's a combination of two or more substances physically. Then let us look at the mixtures we have a liquid to liquid mixtures. Then we have solid to liquid mixtures. Then we have solid and solid mixtures. Then we can get also mixtures here. Now those are three types of mixtures we do have. We have liquid to liquid, we have solid liquid, we have solid. Now let us start with solid to solid mixtures. For example, we can have rice plus stones. We have rice plus stones. Then we can get maize flour obuwunga, maize flour with iron filings obuma, with iron filings buno obuma, or made out of iron filings. Then we can get also coffee berries, coffee berries plus soil or dust. Then we can get rice plus rice husks. Now these are best examples of solid to solid mixtures. Then before leaving solid to solid mixtures, we need to know how do we separate solid to solid mixtures. One, sorting, that is hand picking them ng'omuchere. Then two, using magnetism, using magnets. For example, when we are separating a mixture of maize flour from iron filings, so we use a magnet because these iron filings can be attracted by a magnet, but we cannot use a magnet to remove stones from rice simply because stones cannot be attracted by a magnet. So solid mixtures, we can separate them using three methods. One, we can sort them, that is hand picking, sorting. Two, using a magnet in case we have a magnetic metal in a mixture as our one of the solids. Then three, this is by winnowing, to remove chaffs like husks, especially the cereals. We winnow them, that is winnow, and people feel the word winnow, winnowing, it is winny, then no wingy, so winny no wing, so the word becomes winnow, winnowing. Are we together? All right, let us get another chalkboard here and look at another kind of mixtures. This kind of mixtures, we are going, remember we said a mixture is a combination of two or more substances physically, but when we have a solute plus a solvent, we get that mixture which is called a solution. And one of the solutions we have, it is a salt sugar solution. Then let us look at another kind of mixtures. Now let us look at liquidy mixtures. Let us look at liquid mixtures. For example, I can get water plus alcohol. Alcohol, this is also called ethanol, that is one. Then I can get lange, lange, that is paint. I can get this paint, I add there the petrol. I'm getting. Then I can get blood and I add there water. I can get cooking oil and then plus water, but I can get also petrol then plus water. Now my dear learner, what are you not seeing? There are two now things we are not seeing here. One, we are going to form uniform mixtures. Here we are going to form uniform mixture, and again we are going to form non-uniform liquid mixture. Consider you are moving with me. For example, if I get water, if I get my water plus the cooking oil, this is going to be non-uniform. Water, now if this is the mixture here, now I'm going to have my water here, then on top here I'm going to have cooking oil, and this is going to be water. Why? Cooking oil is going to settle on top simply because cooking oil, it is less dense than water. Now if we get water plus milk, what are you going to get? You are going to get uniform white solution. Now that is going to be a uniform mixture. Over when you get petrol plus diesel, you are getting a uniform mixture. Therefore, these liquid to liquid mixtures, we classify them into two: as miscible liquids and also immiscible. So we have two, miscible and immiscible, whereby let us start with immiscible mixtures. These immiscible mixtures, they are the mixtures, they are liquid mixtures that form that do not form a uniform solution, or that form a non-uniform solution. Examples of these immiscible liquids, that is water plus paraffin, water plus cooking oil, water plus diesel. Are you getting? So they are forming, they are immiscible liquids, meaning that they form non-uniform solution. Now what is the best method to separate them? For example, I want to get my buto back. What am I going to do? I'm going to use a method called a separating funnel. So here we are going to use a separating funnel, and this question came in UNEB 2018 section B. Now this one, and you are studying it just right from primary 5. Now this one, it is my separating funnel, just like this. Then it has a tap down here. It has, let me rub this and I draw it clearly, then just like this. Then it has what's wrong with my pen again? So my dear learner, let us continue. Let us continue with what you've been doing here. Okay, so we've said alright, let us now look at now let us look at what we call now let us look at our, let me first change it here, the color. Alright, now we've looked at the solutes. Now let us look at the solvents. Now solvents, these are the substances that dissolve other substances. So the solvents are substances that dissolve other substances. The best examples here, we have water, we have petrol, we have diesel, we have paraffin, and then we have we are going to have methylated spirit. That one you find in the salons, methylated spirit. Then we have the ethanol and so on. Now here water is taken to be a universal solvent. So water is taken to be a universal what? A universal solvent. Why? It dissolves almost all the solutes. That's why it's called a universal solvent. Then when we get this water, for example, if we get our water plus the sugar, then we are going to form what we call a solution. Then this solution is called salt sugar. It is called a uniform mixture. So a solution is a uniform mixture of a solvent and a solute. Therefore, here we go and we come in with our new word, and this new word is the mixture. So what is a mixture? So a mixture is a combination. We are going to find a mixture as a combination of two or more substances physically. This word must be there. So it is a combination of two or more substances by physical means or physically. And these mixtures, we classify them into three. One, we have liquid mixtures. Two, we have solid liquid mixtures. Then three, we have solid mixtures. Okay, now let us start with the solid mixtures. For example, rice plus the stones. So rice is a solid, stone is a solid. Then we can get also rice plus rice husks. Then we can also get maize flour of wunga, maize flour plus iron filings over Now all those ones are solid mixtures. But before leaving them, before looking at another class of mixtures, let us see how do we separate them. Separation of these solid to solid mixtures. So there are three methods. One, we use winnowing, which is called winnowing, and also we have what we call sorting or hand picking. This is hand picking or sorting or kulonda, and 3, there is what we call the use of a magnet. So when do we use a magnet? We use a magnet when we are separating solid mixture, whereby one of the solid is a magnetic material. It can be attracted by a magnet. For example, maize flour plus iron filings, but we cannot use a magnet to separate stones from maize flour. No. Why? Because their stones are stones for them, they are non-magnetic, so they cannot be attracted by a magnet. Then with winnowing, this is when we deal with cereals like maize husks and rice and rice husks, coffee with those some particles there, sorghum, millet, so those ones we can winnow with them. Then hand picking, that is sorting beans with the stones, then maize with the stones, then coffee, and again also and also rice and stones. Even we can take what we call sieving, but not filtering, but it's called sieving here. So let us get another chalkboard here. That has been solid mixture. Now let us go to what we call liquidy. We have liquidy mixtures, whereby we are mixing two. We are mixing a liquid and a liquid. So these liquid mixtures, we classify them into two. We have what we call the immiscible liquids, the immiscible liquids, and also the opposite becomes miscible. The opposite becomes a miscible liquid. Now let us look at this immiscible liquid. Now immiscible liquid is, this is when you have water plus cooking oil, water plus paraffin, water plus diesel. Now these ones, they are going to form two layers. For example, this is my container, this is water. On top there I mix it with cooking oil. So this one, A is going to be cooking oil and B is going to be water. So the cooking oil is going to settle on top, then water is going to be down. Why? Because this cooking oil, it has a less density, so it is less dense than water. Now before leaving these ones, how do we separate them? If now I've poured the water accidentally in my paraffin, how can I recover it? So this question even came in 2018, section B, PLE. So we are going to use what we call a separating funnel. So here we are using a separating funnel. Even at home you can try it. You can make your separating funnel. Get your bottle, you cut it. You cut the bottom part there, then you have this one where we have the bottle top, then close the bottle top, then pierce the bottle top with a nail, then make a hole, then put a stick there. Now pour water inside here, then you also pour cooking oil, then you leave the mixture to do what? To settle. Then cooking oil on top, then water down. Now this one is going to act as the tap. Now we remove the stick, then this water is going to pass through as now water will go out, then the cooking oil will remain alone. So we shall have separated our water from cooking oil. This is called separating funnel, using a separating funnel. Why is it possible? Because these two liquids have different densities, one with the low, with the less, another one with the more. So that one with the less settles on top, another one with the more, it is down. Alright, so that's how we separate immiscible liquids. That is water paraffin, water kerosene, that is paraffin, water diesel, water petrol, water cooking oil. Now let us look at immiscible liquids here. Now these immiscible liquids, that's when we have alcohol, that is ethanol plus water. When you get that alcohol and you add the water, you get a colorless solution. But it is liquid. Then when you get water plus milk, you get the same. Then when you get water, when you get petrol plus diesel, so you get one thing. We don't have this one settling. Why? All of them, they have almost the same density. That's why they don't form layers. Now how do we separate this? We separate these ones using what we call a fractional distillation method. So here we use fractional distillation method, and in primary 6 we shall discuss that even it is used to separate what we call the crude oil, which is mined, like this one which they are going to mine from lake, which lake is that? Lake Albert, right? So it's going to be crude, it's called petroleum. So to separate petrol, nebajjamu diesel, nebajjamu coal, nebajjamu paraffin, ebyo byonna they use what we call fractional distillation, because these liquids, they have the same densities but they have different boiling points. We shall study this one when we look at temperature. So they have different boiling points. So miscible liquids like ethanol and water, milk, water, petrol, diesel, we separate them using a method called a fractional distillation. Okay, let us look at another type of mixtures. This is solid liquid. So solid liquid, whereby solid it is going to be a solvent, then liquid is going to be a solid it can be let us rub this. So for example, acetones plus water, tea leaves in hot water, then we can get a salt plus water. Now when you look at this, here we are going to use we can use 3 methods. 1, we can use evaporation to dryness. 2, we can use distillation, simple, not fractional, simple distillation. Then 3, we can use filtration. Then 4, we can use decanting. Decantation. Now with evaporation, we apply it when we are separating salt and water to recover our salt from water. This is we boil water to evaporation. So as it is boiling to evaporation, it's going to crystallize. That is evaporation to crystallization. And again, still we can use what we call a distillation method. This one, and the result we get after distillation, it is called a distillate. And this distillate is very, very important when it comes to mixing drugs. That water drips, it is distilled water, and the water they use in recharging of car batteries, it is distilled water, has no mineral salts. And then when you are separating tea leaves from water, here we are going to use filtration method here. Now we are going to put our cotton wool here, then we pour the mixture there. Then as we pour the mixture, then water is going to pass through. Then this water is going to be is called the filtrate, not filtrate, it is filtrate. Then what is going to remain here is going to be the residue. Then the method is called filtration. The method is called what? Filtration. Then with decanting, we can get 2 containers. This one, then the soil particles or the sand particles are there. Then we get another. Then we pour off this. We first wait for this one to settle. Then we start pouring off okutulula. Then ganamazi get to them scientifically is called a decanti. Then these ones are the residues. So that is how we can separate solid liquid mixtures. We can use evaporation to dryness, distillation, then filtration, then decantation. A product of distillation is a distillate, filtration is a filtrate, decantation is a decanti. So we use them to separate solid liquid mixtures. So my dear learner, let me hope that you've understood this lesson 25. So we shall meet in the next lesson. In this lesson, I'm not giving you the assignment, but I'm going to give you a test. So wait for that paper to be answered online. Thank you.